Okay, this is exercise 7.6 on parallel and perpendicular lines. It's from the 3-unit extension 1 textbook. Okay, a lot of this is revision actually from last year, from year 10. So you know that parallel lines have the same gradient, and remember the symbol for gradient is small m. So if you've got line 1 and line 2 and those two lines are parallel, then m1, which is the gradient of line 1, will equal m2, the gradient of line 2. Now, this box here, you actually don't have to learn this. All you have to know is that parallel lines have the same gradient. But if two lines are parallel, their equations will look like this. Now, if you see ax plus by plus c1 equals 0, and ax plus by plus c2 equals 0, notice the ax plus by bits are identical, but the two lines just have a different constant. So if the lines are written in general form like this, the equations will look identical apart from the constant term. So the term in front of the x, the term in front of the y's will both be the same, but the constant term will be different. And now if we look at example 1 down here, it says prove that these lines 6x minus 5y plus 1 equals 0 and 6x minus 5y minus 3 equals 0 are parallel. We can see that the terms in front of the x and the y are both the same, but it's not enough to say that. What you have to do to prove that those two lines are parallel, you're going to have to put both of those equations into y equals mx plus b form, and then state the gradient of each line, and then say that the gradients are equal. So we'll look at the first line, which is 6x minus 5y plus 1 equals 0. If we write that in y equals mx plus b form, we'll take the 5y to the other side, and we'll get 5y equals 6x plus 1. So I've just taken that over there. And now dividing through by 5, we get that y equals 6 on 5x plus 1 on 5. So therefore the gradient of this first line is 6 over 5. So the gradient of line 1 there is 6 on 5. If we look at line 2 here, we've got 6x minus 5y minus 3 equals 0. Taking this 5y to the other side, we get, sorry, I'll just fix that up. So we take this over, we get 5y equals 6x minus 3. Dividing both sides through by 5, we get that y equals 6 on 5x minus 3 on 5. Therefore, the gradient of this second line is also 6 on 5. So we've got here that gradient 1 equals gradient 2, which equals 6 on 5. Therefore, the lines, those two lines, are parallel, because they have the same gradient. Okay, so you need to basically to prove that two lines are parallel, you need to find the gradient of each line. Then you need to make the conclusion that the gradient of the first line equals the gradient of the second line. Therefore the lines are parallel because they have the same gradients. Okay, now we'll look at the second. Now in this question here, find the equation of the straight line passing through this point and parallel to this line. Now, whenever you want to find the equation of a line, there are a few methods you can use, but always the point gradient formula will always work. So I'm going to write down what the point gradient formula is. Now, our point gradient formula is, now you did look at this in the last exercise, so the point gradient formula uses a point and a gradient. So it is y minus y1 equals m bracket x minus x1. So you will use the point that you will use will be x1, y1, and the gradient that you will use will be m. So to use the point gradient formula, we need a point x1, y1, and the gradient m. Now, we've got a point here, but we need to find the gradient of the line parallel to this line. Okay, so find the equation of the straight line that passes through this point. So we've got the point, but we don't have the gradient. But the gradient of our line is actually parallel to this other line. So what we're going to do, we'll look at this other line, x minus 3, y minus 7 equals 0. We need to find out what the gradient of this line is, so we'll put it into y equals mx plus b form. So first let's take the 3y over to the other side, and we get that 3y equals x minus y. And dividing through by 3, we get that y equals x on 3 minus 7 on 3. Therefore, the gradient of this line is we have to look at what is in front of the x, and that is a 1. 1 over 3 is the coefficient of the x. So the gradient of this line here is a third. So the gradient of the first line is 1/3. So that's the gradient of this line here. So therefore, the gradient of the line parallel to this line will be the same. So gradient of line 2 will also be a third, because parallel lines have the same gradient. So now the question becomes the following. Find the equation of the straight line passing through this point -1, 5, and instead of and parallel to this line, we say find the equation of the straight line passing through this point -1, 5, and with gradient 1/3, because the line parallel to this line has gradient 1/3. So therefore our our gradient is 1/3, and the point that we're going to use, x1, y1, is -1, 5. So there's my gradient, there's my point. So now the equation of your line, you will use y minus y1 equals m, bracket x minus x1. This is my point, x1, y1. So it becomes y minus 5 equals, sorry, that's just come off the page. So y minus 5 equals, gradient is a third, x minus x1 is -1. So if we, what we can do, we can either leave this equation in y equals mx plus b form, or we can write it in general form. Now the question is written in general form, so we'll write our answer in general form. So what are we going to do? We need to get rid of this 3 down here. Now this is really 1 bracket x plus 1 over 3. So to get rid of this, divide by 3, we just multiply both sides by 3. So we'll get 3, so we'll multiply through by 3. That will get rid of this 3 down the bottom. So we get 3y minus 15. Now, if you times this side by 3, the 3 down here cancels with the 3, and we're just left with x plus 1. Okay, so we're timesing this by 3, this by 3. So we get 3y minus 5 times 3 is 15. Now, this is 1 bracket x plus 1, close bracket, all over 3. Now, that is one term over here. Okay, because this is in brackets. If you times this by 3, the 3 on the top cancels with the 3 down the bottom. You're just left with x plus 1. Now, to put this in general form, the x, it has to be in the form ax plus by plus c equals 0. Now, my x is positive on this side, so I'm going to take everything over to the right-hand side. I'm going to get x, bring this over here, minus 3y. I've got plus 1 here, and I'm going to bring plus 15 over, so I get plus 16 equals 0. And that is the equation of the line that passes through the point -1, 5, and parallel to this line, x minus 3y minus 7 equals 0. Okay? Now for example 3. Okay, in example 3, you have to find the gradient of the line that is parallel to the line that makes an angle of 135 degrees with the x-axis in the positive direction. Now I'm just going to draw that. Now I don't know where along this line that, the line could go through here, it could go across here, but it makes an angle of 135 degrees. So it doesn't matter where the y-axis is. I'm just going to put my line like this, that the angle, see, this is my x-axis here, and this line, this is my line here, it makes an angle of 135 degrees with the positive direction of the x-axis, okay? So therefore the gradient of that line, the formula is, the gradient is m equals tan theta, so m equals tan of 135 degrees. Now you can enter that in on your calculator and you will get -1, or because you're basically in quadrant 2, because 135 degrees is quadrant 2, okay? We can say, well, the gradient is, if we want to write that as an acute angle, 135 degrees, you've got 45 degrees left over there, but it's quadrant 2, so you get negative tan 45. Now, you might get a little bit confused because I've put the y-axis there. I mean, I can put the y-axis straight here, and that might be less confusing for you. But with this particular question, even though this line is on an angle of 135 degrees with the positive direction of the x-axis, that line could have been over here, or even over there. It wouldn't matter. Okay, it doesn't have to pass through the origin here. okay? But I've just done it there for you so that you can see that, yes, this 135 degrees brings us over into quadrant 2. The gradient would be the same. The acute angle here would be 45 degrees, so the gradient is negative tan 45 degrees, which is negative 1. So therefore the gradient of that line is negative 1. Now you could just enter tan 135 in on your calculator and you would get negative 1. But here, because we know we've got exact values, I've written as negative tan 45, which is negative 1. Okay, so that you can use your exact values, because sometimes you might have the angle of tan of 120, so you need to do tan 120. That would not be an exact value like we've got here. All right, you would get negative root 3 in that case. Okay, so it's best to try and use your exact values rather than using your calculator. Okay, now with the next one, find the equation of the line that passes through the point 2, 3 and parallel to the line that makes an angle of 45 degrees with the x-axis in the positive direction. So remembering, when you need to find the equation of a line, you need a point on the line and you need the gradient of the line. Now we've got the point. The line passes through this point 2, 3. So we've got the point, but this information parallel to the line that makes an angle of 45 degrees with the x-axis in the positive direction, that all gives me information about the gradient. So we know that the gradient of this line that makes an angle of 45 degrees with the positive direction of the x-axis, if I do a little sketch, okay? So let's say this line here makes an angle of 45 degrees with the positive direction of the x-axis. That line there has a gradient of 1 because it's m equals tan theta. The gradient of the line is tan theta. In other words, in this case, it's tan 45, which is 1. And my point that I've got is 2, 3, which is x1, y1. So therefore, the equation, so this line here has a gradient of 1. Your line, or our line actually, that we're trying to work out, its equation, passes through the point 2, 3, which is up here, and it's parallel to this line, so it has the same gradient. Okay, so our line has a gradient also of 1 and it passes through the point 2, 3. So our line has a gradient of 1. Okay, actually I'll call this one M1, the gradient of the initial line. Our line, I'll call it M2. Okay, so this line M1 has a gradient of 1. Our line, the gradient of our line, and I'll call our line line 2. It also has a gradient of 1, so our gradient is 1 and our point is 2, 3. So that's my m and my x1, y1. So the equation of the line is y minus y1 equals m bracket. I'll just fix that up. So it's y minus y1 equals m bracket x minus x1. So we get y minus 3 equals 1 bracket x minus 2. Right, there's no fractions here that we need to get rid of. We can just expand. Y minus 3 equals x minus 2. Now it needs to be in a y equals, we can either put it in y equals mx plus b form or general form ax plus by plus c equals 0. If we put it into y equals mx plus b form, it'll be y equals x minus 2 plus 3 or y equals x plus 1. If we simplify that, that's y equals mx plus b form. And if we put it in general form, remembering the coefficient of the x needs to be positive, so we need to bring this y over, and we'll get x minus y plus 1 equals 0. Okay, so that's y equals mx plus b form, and this is the equation of the line in general form. Okay, perpendicular lines. Now, if two lines are perpendicular and those two lines have gradients that we call m1 and m2, so if two lines with gradients m1 and m2 respectively are perpendicular, then what we find is that if we multiply the two gradients together, that their product will equal -1. So it means that m1 times m2 equals -1, or one of the lines will be the negative reciprocal of the other line. In other words, the gradient of line 2 will equal -1 over the gradient of the first line, line 1. Okay? Now, for example, If your line 1 has a gradient of 5, then line 2 will have a gradient of the negative reciprocal of that. So we do, if this is positive, your perpendicular line is negative, and you flip this here. So to flip 5, which is really 5 over 1, it becomes 1/5. So if the first line has gradient 5, the second line that's perpendicular to it will have gradient -1 on 5. If your gradient of your first line is 2/3, then the line perpendicular to it will be the negative reciprocal of that. So to flip that, to do the reciprocal of that, you get negative, and then you get 3/2. So it's the negative reciprocal. Now that already is in fraction form, so you just flip it over, because you're doing 1 divided by 2/3, or -1 over 2/3, which will be -1 times 3/2, becoming -3 on 2. So that's just some examples of, if you know the gradient of one line, how to find the gradient of the line perpendicular to it. You just do the negative of it. If this one's positive, this will be negative, and then you just flip the fraction here. This fraction you can think of as 5 over 1, so you flip that and it becomes -1/5. Okay? Now, if you look at two lines that are perpendicular and they happen to be in general form, then this is how they will look. You'll have ax plus by plus some constant equals 0, and the line perpendicular to it will be like the coefficients. The coefficient of the a here will, of the x, sorry, here will be the coefficient of the y here, but it'll be the negative of it. And here, the coefficient of the y here will be the coefficient of the x here. But notice one of them will be negative, the other one will be positive, okay? And they may or may not have different constants, okay? More than like, yes, okay? All right, let's look at an example here. So the first example is find the gradient of the line perpendicular to the line with x-intercept 3 and y-intercept 2. Now, what you'd have to do is sketch this. Now, if the x-intercept is 3 and the y-intercept is 2, then I'm going to just join this line. What we can do, we can see that this gradient, this line, sorry, here has a negative gradient, and we're going to need to find the gradient of this line. Now, obviously, I have to go up 2 and across 3, but I'm going up 2, but I'm going backwards -3. So the gradient of this line is 2 over -3, or -2/3, okay? So that's the gradient of this line, okay? Remember, it's a negative gradient, which is why we've got a negative. So it's 2 over -3, which is the same as -2/3. That's the gradient of that line. Now the gradient of the perpendicular line, so the line perpendicular to that one, so the perpendicular line, I'll put M2, that is the negative reciprocal of that. So this is a negative, this has to be positive, and then we flip it. I've got 2/3 here, I get 3/2 here. So the negative reciprocal of -2/3 here is positive 3/2. If this one's negative, this one's positive. That's 2 on 3, this is 3 on 2. Okay, so that's our first question there, our first example. Now example 6. Okay, and in this example we are finding the gradient of the line that is perpendicular to the line making an angle of 120 degrees with the x-axis in the positive direction. Okay, so I'm just going to draw that my line makes an angle of 120 degrees with the x-axis. Here's my x-axis, and that's my positive direction of my x-axis. So the gradient of this line here, this one here, I'll call it line 1, it's tan theta, or tan 120. Now I need to write that as an acute angle, so that the related angle here is 60, so it's tan 60, but because this is a quadrant 2 angle, it's negative tan 60 because of all stations to central. Tan 120 is the same as negative tan 60, which happens to be -√3 as an exact value. So in other words, the gradient of this line here is -√3. Now any line perpendicular to that line, I can just draw one in here. If the gradient of this line is -√3, then the gradient of this line will be positive. Okay, the line perpendicular to that will be positive. So M2, the perpendicular line, I'll go perpendicular line, M2, its gradient will be the negative reciprocal of that. Now I've got a negative here, this one will be positive. This is negative root 3 or negative root 3 on 1. So this will be the flipped version of that, which is 1 on root 3. So we need the negative reciprocal of this. So negative here, positive there, and then flipping root 3 on 1 becomes 1 on root 3. So therefore, the gradient of the line perpendicular to this line is 1 on root 3. Okay, all right, so I'll just write that up here, that this line would have gradient 1 on root 3. Okay, in the next question, find the equation of the line passing through the point negative 2, 1 and perpendicular to this line here. Now remember, to find the equation of a line, we're going to use the point gradient formula, and there's my point, x1, y1, and this information here gives me information about the gradient of the line that I want to find. Now, looking at the line that we've got here, so line 1, this is 2x plus y plus 3 equals 0. Sorry, just focusing that. Okay, so the first line, line 1, is 2x plus y plus 3 equals 0. If I rearrange that into y equals mx plus b form, I'm going to keep the y here because it's positive. I'll take the 2x and the 3 over, and I get y equals negative 2x minus 3. So therefore, the gradient of this line here is negative 2. Now, I want the equation of the line passing through this point, but perpendicular to this line. So this line has gradient negative 2. Line 2, which is the perpendicular line, perpendicular to line 1, that has gradient m2, which is the negative reciprocal of that. So it's if this is negative, this one's positive. This is 2 over 1. This will be a half. So my line that I want has a gradient of a half. So therefore, this is what we've got, that the gradient is a half and that the point that we're using is negative 2, 1. So that's my gradient, that's my point. So my equation of my line, so the equation of the line is y minus y1 equals m bracket x minus x1. And substituting that all in, we get y minus 1 equals the gradient is a half, x minus negative 2. So this becomes y minus 1 equals a half, x plus 2. Now this is 1 bracket x plus 2 over 2. To get rid of this divide by 2, we need to times through by 2, or times the other side by 2, and we'll get 2y minus 2 equals x plus 2. What we're really doing is multiplying both sides by 2. So if we times this side by 2, we get 2y minus 2. If we times this side by 2, the 2 down here cancels with the 2 up there, and we're just left with the x plus 2. And putting this into general form, because this here is written in general form, we need to keep the x as a positive. The coefficient of the x needs to be positive, and it is over here. So we'll just take the rest of it over the other side. And we get x, that stays the same. The 2y has to come over, and we get minus 2y. This minus 2 has to come over as a plus 2. So we've got plus 2 there and another plus 2, which gives us plus 4 equals 0. So this is our solution. X minus 2y plus 4 equals 0 is the line that passes through that point negative 2, 1, and it's also perpendicular to this line here. Okay, now in example 8, we need to show that these two lines here, 7x plus 3y plus 2 equals 0, and 3x minus 7y equals 0 are perpendicular. Now we can't just say, well, this is in the form ax plus by plus c1 equals 0, and this is in the form of bx plus minus ay plus c2 is 0. It's not enough to do that. Just like, I showed you here, you don't use that, okay? It's just for you to notice that the coefficients of the x and the y here are swapped. There'll be a negative positive pair, but the other ones will be the same, like they'll both be positive. But what you need to do to show that they're perpendicular, you'll have to find the gradient of both lines and then show that m1 times m2 equals negative 1. So let's do that. So the first line is 7x plus 3y plus 2 equals 0. So that's line 1. And we get that 3y equals negative 7x minus 2, keeping the y's on this side and taking the x's over and dividing through by 3, we get that y is negative 7 on 3x minus 2/3. And so the gradient of this first line is negative 7 on 3. Now we'll look at the second line, line 2. And we've got that line 2 is 3x minus 7y equals 0. Taking this 7y to the other side, we get that 7y equals 3x. So the gradient of this line here is dividing through by 7 now. You get 3 over 7x. So therefore m2 equals 3 over 7. Now, you can't just say, well, these are negative reciprocals. I mean, they are, but you need to show that m1 times m2, you have to show that it's negative 1. So what we're going to do, we'll write down what m1 is, and that's negative 7 on 3, and we'll write down what m2 is, and that's 3 over 7. So m1 times m2 is negative 7 over 3 times 3 over 7, and you will get that the 3's cancel and that these 7's cancel, and you're left with, and of course you put 1's in their place, and you're left with negative 1 as your answer. So therefore, line 1 and line 2 are perpendicular. And the reason is because m1 times m2 is negative 1. Okay? And that's how you prove that two lines are perpendicular. Okay, now this is example 9. And the question is to find the equation of the perpendicular bisector of the line passing through 6, negative 3 and negative 2, 1. Now you're asked to find the equation of a line. And of course, to find the equation of a line, we're going to use the point gradient formula. So let's just see, let's just try and visualize what this question is all about. We want the equation of the perpendicular bisector of the line passing through 6, negative 3, and I'll say, well, that's roughly down here. And the other, and negative 2, 1. So here's my line. So this is my line. And now I don't want the equation of this line. I want the equation of the perpendicular bisector of the line joining these 2 points. So I don't want the equation of this line. I need the equation of the line that passes roughly through there. Now, a perpendicular bisector of a line, so I haven't drawn that very well. Bisect means this line is going to cut this one in half, so I need the midpoint of negative 2, 1 and 6, negative 3. So I'm going to need to find out what this point is, and it's the midpoint. So I'll do that first. And then I'm going to have to find the gradient of this line. And I know that this line is at right angles to it because it's the perpendicular bisector. So once I find the gradient of this line, I can then work out the gradient of that line. So first thing, let's find the midpoint of the line joining the points negative 2, 1 and 6, negative 3. So midpoint formula, remember I add the x values together, so I get negative 2 plus 6 over 2, so I'll just call this the midpoint. And I add the two y values together and I get 1 plus negative 3 over 2. And negative 2 plus 6 is 4, 4 on 2 is 2. And 1 plus negative 3 is negative 2. And negative 2 over 2 is negative 1. So this point here has coordinates to negative 1. So I need to find the equation of this line. I already know the a point on that line. I just need to find out its gradient. Now, first we can find out the gradient of this line here. I'll just call this line 1. So this is the midpoint. Okay, that's that point. Now I want the gradient of line 1, so I'll call it m1. Remember the gradient formula is y2 minus y1 over x2 minus x1. So I've got 1, that's x1, y1, x2, y2. I'll go 1 minus negative 3. So I've got 1 minus negative 3 over negative 2 minus 6. Negative 2 minus 6. Now 1 minus negative 3 is 1 plus 3, which is 4. Negative 2 minus 6 is negative 8. So 4 and negative 8 happens to be negative 1/2. Now, so therefore the gradient of this line 1, it's negative 1/2. So the gradient of this line will be the negative reciprocal of this. So line 2, the perpendicular line, will have gradient. Now, if this is negative, this one will be positive. This is 1/2. This will be flipping 1/2. You get 2 over 1, or just 2. Okay. So the gradient of this line, this is line 2. M2 happens to be 2. So now I've got enough information to find the equation of my line. So using my gradient is 2, and there's my point there. That's my x1, y1 is 2, -1. So the equation of the perpendicular bisector will use y minus y1 equals m x minus x1, and we get y minus -1 equals 2 bracket x minus 2. And I get that y plus 1 equals 2x minus 4. And therefore, we can either put this in y equals mx plus b form or in general form. Putting it in y equals mx plus b form, we get y equals 2x minus 4, bringing this plus 1 over, I get 2x minus 5. Or putting it into general form, I'll keep the 2x over here because it's positive, the coefficient of the x is positive. I get 2x, bringing this y over, 2x minus y minus 5 equals 0. And just remembering that in general form, that it's ax plus by plus c equals 0. So the x has to go first, and always the coefficient of the x is positive, and then the y term next, and then the constant, and then equals 0. Okay, now for exercise 7.6, if you could please do the following. Question 1E, H and J. Questions 2C and G. Questions 3, 4, 7, 8, 9, 10, 12, 13 and 15. Thank you. Next video, it will be on exercise 7.7.